Something that we will cover today is enough material that the Master Set 2, if you've, has anyone started Master Set 2? Got a sort of, maybe a couple other head shakes of maybe it counts, I don't know. So we're gonna go into some of that. As said before, since half the course is officially online, some of the material has to be covered through the videos, or we cut out half the material, which I really don't want to do. Too much cool stuff in physics. Okay. Not everyone thinks it's cool, but those people are wrong. Any other questions right now? All right, so let's start talking about force. What is a force?
Push or pull.
Yep. Usually not the official definition. Do you happen to know what the official definition is?
Something about acceleration.
There is some, yeah. There is acceleration in there. Pardon?
Mass times acceleration?
That isn't really the definition of force. That happens to be a underlying truth, sort of.
Vector quantity?
It is a vector quantity. I was going for the really unhelpful definition. Acceleration's in it, and I'm going to, spoiler alert, I'm about to tell you. An influence which might cause acceleration. I think push or pull works a whole lot better. As we talked about last time, it is a vector quantity, which means that there's a magnitude and a direction. Let's talk a little bit about units. The symbol I use for force is capital F. And since it's a vector quantity, put the little symbol over top of it. If I drop the vector symbol over it, what I'm talking about is just the magnitude. So this would be just the magnitude of the force. And when I put the brackets around it, this is saying the units of. Some textbooks will, not Hewitt, but we'll do that to indicate we're talking about units, but this is, we're talking about units. Units of the magnitude of force. And you'll find if you're not used to sort of the physics approach, we basically don't like writing. And so we come up with shortcuts for writing it. So instead of writing out the units of the magnitude of force, we just put an F in brackets there, and that just seems a whole lot easier. Well, what's a unit of force? Anyone? That classic right there, that's the one that we will deal with mostly. Another unit of force? I think somebody said something, but I missed it. Not a unit. Oh, all of you know another one. Pardon? No. No. No, I'm going to overdo it. No!
I didn't hear what she said. Kilograms. Oh.
Yeah, now purge that from your thoughts. That is not a unit of force.
Gravity?
No. Gravity is a type of, well,
Pounds.
Wait.
gravity we'll talk about and why I cringed at the word, but pound. Weight is a type of force. All right, so let's go back to my over-exaggeration on the word no earlier. Kilogram is not a unit of force. What is it a unit of? Or of what is it a unit?
Mass.
Yes. And I'm going to put a little SI down there just to indicate we're talking about the international standard, or in my French pronunciation will be horrendous, at least that's what my French teachers used to tell me, Standard International. That's why it's SI instead of IS. Anyone with a even halfway decent French pronunciation? Then you're gonna stuck with what I said. All right. Standard International or International Standard. There are certain units that are part of the International Standard. Kilogram is part of the International Standard. Newton is part of the International Standard. Meters is International Standard. Seconds. Candelas, we'll never deal with. There's been a question I've asked in past quizzes where I've given the mass of an object or a person, and I said, how much does the person weigh? And there's a really simple way of figuring out how many newtons it is, and then they convert it over to pounds, like weight can only be in pounds. Newtons is perfectly legitimate for dealing with weight. All right, so let's do some basic problem here. I've got a box, and I'm pushing on it with a 5 Newton force, and I push on it with a 3 Newton force. What is the total force acting on the box?
8 newtons.
Sorry, I'm not saying no. I was just hoping someone would throw in another piece to it. Ethan's mentioned it, I think, twice.
Vector.
So, what does that tell you? What about a vector?
Direction.
Okay, so 8 newtons is not sufficient.
8 newtons to the right.
Yep, there we go. 8 newtons to the right. So total force, 8 newtons to the right. I will go ahead and write it out to the right. Now, as I said before, physicists really don't like writing much, so we got to have some shorthand to the right. Oh, all those words. How can we do this more simply?
Plus and minus.
I heard several voices and missed all the detail.
Plus and minus.
Okay. How can a plus or minus help us?
Because it's like a number line.
What was the last one?
It's like a number line. And it goes back and forth.
Okay, we have to do one thing before we get away with plus or minus. There is a way of dealing with this with just a plus or minus. We have to decide what is the positive direction.
I'm pretty sure the right is negative.
You said to the right is negative? You saying it's positive? Did you say negative just a moment ago?
No, I said that.
You said you went to the right negative and you went to the right positive. Which one of them is correct?
The right.
Does anyone want to defend Isabella?
I guess you can make it any way you want.
Which way is positive?
Whatever way that you want.
Yep. I have no problem making to the right positive. I have no problem making to the right negative. But I need to define it. So we'll just stick with, we'll say to the right is positive for right now. So once I've done that, I've now said that to the right, anything to the right is positive. So I can just write 8 newtons, or just to emphasize it, positive 8 newtons. Yes, Pat?
I'm sorry if this might be, like, not a good question, but so would that mean that up will also be positive?
No, let's hold off on the two-dimensional problem at the moment.
Okay,
Or do you want me to just shift it so that both are pointing upwards?
no, it doesn't matter.
We'll get to up, down, left, right. We'll combine it all at some point.
Okay,
All right, so we have now a short way of saying to the right. If we instead, I got 5 newtons going to the right, I got 3 newtons going to the right, and this time I want to make to the left a positive. Now, whatever I say is the positive direction, opposite is negative. So I don't have to say that positive this way, negatives that way, it's understood. If I say positives that way, that's got to be negative. I'm not saying anything about up or down. So in this case, what's the total force acting on the box?
Negative 8 newtons.
I think it's just said,
Negative 8 newtons.
yep. So if I ask the problem, if I give you a box there and I said I have a 5 Newton force pointing to the right and a 3 Newton force pointing to the right, and the person just said 8 Newtons, I have no idea if that person's right or not unless they have told me one of these. And it's just simple, draw an arrow, put a plus sign there. You've now defined it. All right, any questions before I make it look more complicated? Yes?
I'm not really sure if we're about to get into that or not, but, can you do a situation where, like, say there was 5 to the right and then 3 to the left, or were you about to do that?
I was gonna, that wasn't the next thing, but it was the time one after that.
Oh, okay, then never mind.
You're ahead of your time. All right, so now, box. 5 Newtons pushing on it and 3 Newtons pulling on it. What's the total force? And let's just, for the sake of expediency, we'll just say to the right's positive. What's the total force acting on the box?
Plus 8 newtons.
I think it was just said. All right. Push or pull, it doesn't matter. And from a physics point of view, whether something's being pushed with 5 Newtons or pulled with 5 Newtons, it's the same thing. If you were designing a bridge or multi-million-dollar equipment, then yeah, you might want to get into something more than that. But right now, we're not going to worry about that difference. Let's still keep to the right as positive. By request. Say it again.
2 Newton is positive.
Yeah.
Or to emphasize it. I think it's the first time I had somebody hasn't immediately blurted out 8 Newtons. Direction matters. Now I'm going to take this simple example. I hope all of you can see where a 2 might come from. You might not have been thinking 2 Newtons, but I'll show you another way of looking at it.
Did y'all subtract because y'all are using like positive and negative, or is it because you're supposed to subtract things like that?
I would say both. But hopefully the next thing I'm going to do is going to clear up at least part of what you just asked. When I'm adding vectors, if it's a one-dimensional problem, so everything is just left, right, or up, down, just I can draw a line and everything is parallel or anti-parallel to it. I can turn this into just a basic problem. I have 2 forces here, and I want to find the total force. So I'm just going to add them. That's 5 Newtons is to the right, and I said to the right is positive, so I got positive 5 Newtons. plus, because I'm adding forces together. I got a 3 Newton force here going to that way, so it's a -3. Or the math problem is 5 minus 3, which is 2. Because they're in opposite directions, the signs have to be opposite. One's positive and one's negative. And so you're just so you're either subtracting the magnitudes or adding a negative, depends on how mathematically you want to look at it. Did that answer your question?
Yeah.
Okay. Other questions up to here? Elaine?
With it being positive and negative, if we just wrote 8 newtons, could we do the assumption that it's positive unless labeled negative, or just go ahead with the positive and negative?
I mean, for the final answer, could you have just written 2 newtons? Yeah, if it's a positive number, you don't have to write the plus sign.
Okay.
If it's negative, you have to write the minus sign. Just like normal math. All right, let's make this more complicated. Now what's the total force?
8
It's still 8 newtons, right?
No.
Like 5
Which
newtons.
way is positive and negative?
All right, what do you want to make positive?
You're right. And, okay, so that means positive 8 newtons. No?
We got to do something more than that.
Okay,
That's why it's more complicated.
okay.
Wouldn't they be pushing against each other, so they're, instead of just going this way or this way, it would go?
Yeah. So there's more force to the right than there is up. The net force would be in sort of that-ish direction. Yeah.
Would you have a force of 3/5 slope going diagonally at that angle?
Yes. Yeah. Yeah. Slope would be 3/5. But that sort of gets into what's called polar notation. I want to avoid that. If we're dealing in 2 dimensions, we can't just get away with just a plus or minus. And now we have to bring in something else. I'm going to write it out the long way just so that you might appreciate the short way. So the total force here, 5 newtons to the right, plus 3 newtons up. Which works fine unless you're looking at a piece of, if the board were down on the back, then, up, we're just sort of saying away from us. Unless, of course, somebody's on the other side, then it would be towards them. We need some way of identifying this.
So would that be the answer, or is that where like formulas
All
or
right.
like solving something comes up?
This is a correct answer. This is not the final form we're going to use.
Okay.
All right. So once we get into 2 dimensions, or more than 1 dimension, suddenly we have this picture of, do we ever deal with fractional dimensions? Not in here. Physicists don't feel like writing all that stuff out, so they came up with this thing known as the unit vector. It is a vector, which means it has a magnitude and direction. What is the magnitude of a unit vector? What is the magnitude of a unit vector? I think it was just said.
Force displacement?
The magnitude, looking for a number.
Is it 1?
It is 1. The magnitude of a unit vector is 1. Because the whole purpose of a unit vector is to tell you what directions are what. So the magnitude of a unit vector. And the absolute value sign around it is just the shorthand for saying magnitude is 1. No units, there are no units associated with the unit vector. Or if you do want to put units in there, then welcome to senior level physics. We will assume never. And the direction, because vectors all have a magnitude and direction, the direction is whatever I say it is. So what I'm going to do here is, instead of just saying plus is that way and that way, I'm going to say to the right is I hat. Now this mark right here, this is another vector symbol. When you see the hat like that, when spoken, it is hat. If you're using OpenOffice or LibreOffice, that is the shorthand. If you're writing an equation out, hat is the key word there. It's not just something I'm saying. It's in French, it has some other name, but judging from reaction earlier, I'm assuming no one knows what the French accent mark is that looks like that. Okay. I never remember, so we'll stick with hat. So I'm saying I hat's this way, and I'm going to say J hat is that way. So instead of saying to the right, what I'm going to say here, this is 5 newtons I hat. I'll actually draw a little bit better than what I was doing there. Plus 3 newtons J hat. And that's the answer. I've defined that I hat's to the right. I said J hat was up, and so that works.
So when it's like that, you don't have to do it in math, you just write it like that.
I would claim that is math because I got a plus sign in there, but yes, that we would stop. Depends on the nature of the question. We could take it farther, and I will in a moment. But if all I said was what's the total force and you wrote that, you defined it and wrote that, you're good to go. Is there a hand back here? Is it Brittany?
Yeah, so that was